Hello, everybody. I'm Stephanie C. from Thinking Machines, and I'm very pleased to be presenting to you at this year's virtual Spatial Data Science Conference 2020. I was very much looking forward to this, doing this in person, and I really hope we get to meet each other in person next year. I'll be spending 30 minutes now talking to you about useful frameworks for using spatial data sets for short-term tactical analysis and long-term strategic planning. So this is much more of a frameworks-driven and insights-driven presentation. So if you're interested in code and getting really deep into the weeds of how to use machine learning for feature extraction and inference, please do hop on over to the Thinking Machines blog. You do not need to listen to me talk for 20 minutes. It's stories.thinking machines. Check out the link there. And if you spot anything of interest to you at any point, feel free to just drop me a note. My email is steph@thinkingmachines. All right, so let's go. Quickly to introduce my team, we are a data science consultancy that builds AI and data systems for larger organizations to make decisions. We're headquartered in Southeast Asia between Manila, Philippines, and Singapore. But we work with organizations all over the world on both data systems problems and specifically spatial data analysis. It's been a really fantastic time to be a data scientist focused on the intersection of artificial intelligence, enterprise data systems, and spatial analytics. We've done some pretty interesting work for both the private sector and in the civic sector. Just to point out, something really interesting we've just done, or we did in 2019, was to work with IMAP in Colombia to use machine learning to tag potential refugee settlements, people coming across the border from Venezuela, tagging them and working with IMAP and Premise to be able to validate really quickly whether those are true refugee settlements and to be able to direct aid to them. And that work is work that is only possible at scale with the use of machine learning on large data sets of satellite imagery. I'll be talking a little bit more about satellite imagery as a source of data later on. But really the main focus of my team for all of 2020 and probably for most of next year is on responding to COVID-19. So the interesting thing about COVID-19 is that it's not just a public health crisis, it's a public health crisis with a spatial dimension. The very nature of how COVID spreads demands that we understand the shared spaces that we all move through. So especially in countries where the focus is on management, case management, and rate management rather than total elimination, we really badly need spatial analytics and spatial data sets to make the right decisions, both at the government level and at the corporate company level. And truly, the bedrock of it, before we get into anything fancy, anything machine learning, AI, geospatial data, really, truly, the bedrock is having good digital data systems. For a lot of organizations, this has been a digital transformation crisis. All the work that they had not done in the last 5 years to get their teams ready for remote, to be able to see data in near real time and respond and make decisions at that scale. All of those chickens are coming to roost. Like many other data analysts, I kind of made this face. Like many of you, I made this face when I saw this headline from The Guardian on how using an XLS format may have caused the loss of 16,000 test results in England, which is painful, but completely understandable if you think about the way organizations have legacy systems and have legacy thinking with regards to their data use. Satya Nadella, the Microsoft CEO, said that 2 years worth of data transformation had happened in 2 months, the first 2 months of this crisis. I frankly expect 12 years worth of data transformation to happen in the first 12 months of this crisis. This isn't just a problem for health organizations either. Every single org needs to rethink their data. What kinds of tools do they use? What kinds of analysis do they do? What kinds of data streams do they have? And how quickly the organization can use data to make decisions. So bedrock, step one, please build a good digital, build up your digital systems. Once you have that, now we can put our hats on as spatial data scientists and think about this question. How do organizations use spatial analytics and AI for tactical monitoring and long-term strategic planning? I'm going to share a lot of thoughts and insights and a framework that my team's developed over the last 6 months of working with governments, multinational institutions, from small brick and mortar companies to big enterprise organizations. There is going to be a bit of a focus on Southeast Asia because that's where we primarily operate, but I think these lessons are truly applicable anywhere. So let's start with the tactical level, right? When it comes to tactics, you can build a useful tactical data system in less than 10 days. I truly believe this. We've done this multiple times. It's not going to be a perfect tactical data system, but it is going to be useful. Once you take 4 months to go through a whole procurement cycle, you've already missed, like 3 waves of COVID in the US? It really doesn't make sense to operate in a legacy environment where the business unit constructs their use case, their report hypothetical, and they forward that request over to a different data analytics, data science, or IT team, whatever you call that organization. That team then puts this request in their backlog, writes a SQL query for it, takes a few days, ships it back to the business unit team. Business unit team checks it, says, oh shoot, we needed 2 more columns. This whole process has taken a week and a half. In the meantime, your whole business has lost 20% of their revenue. That's not usable. That's not useful for the situation we're in. The good news is you can build a useful tactical data system very quickly with good fundamental data infrastructure and good tools for iterative daily analysis. It is so key to have tools that allow you to iterate really quickly. In this example, you have a business unit team and a technology data team kind of going back and forth with each other. You don't want that. You want one team with the ability to, you want every single person on that team to have the ability to write queries, view them on a spatial layer, to be able to conduct analysis, to be able to change that analysis on the fly and respond to everything on the fly. So in other words, you need a system that has, if you look at this little chart I prepared, a COVID-19 data store. Ideally, this is cloud-based. This is the only way this works if we're all remote. You have a data store that can generate exportable data sets or reports, that can work with data visualizations and dashboards, that have interactive maps. So that's a missing piece I find from many off-the-shelf pieces of analytics tooling. They are really for data scientists and analysts thinking columnarily, not spatially. So that is like an added factor that we all need. This can be built on pretty much anything, as long as it's cloud-based. You can do this on AWS. You can do this on Google Data. You can do this on Google Data Studio, hooked up to like Google Sheets. If somebody designs it well, you can do this on Tableau connected to your Microsoft, a Microsoft SQL server. There's so many different pieces of software. It really doesn't matter what you use. What matters is the ability to spin up really quickly, and to iterate really quickly, and to give analysts the ability to modify these data sets on the fly and operate with large quantities of data pretty quickly. Having said that, you also need to have different data streams that you might not have thought about or might not really have access to, have had access to previously. So what are those data streams? I want to point out 3 that we've found to be particularly useful. So these new data streams include public health data sets, consumer behavior data sets, and mobility data sets. And I'm going to spend a few minutes talking about the kinds of insights you can see in these data sets, and why I think it's very key now to have these data sets coming in quickly. So Why fast, right? Fast is like the word of the day. Fast because the behavior of our customers and our public health situation is also changing incredibly rapidly. Between March 10 to March 17, the world went from 50,000 to 96,000 active cases. You could be a relatively stable country one moment with no new active cases in the last 7 days, and suddenly have clusters pop up that you have to react to and deal with uh, within 5 hours of hearing the news. So think about the example of Seoul and how they've had to deal with several outbreaks that they've now continued to manage. So if you're operating in that sort of environment, you really cannot wait 3 months for a consumer behavior index report. You really need it on a day-by-day basis. So no brainer. Get as much public health data as possible. This is the first no brainer data stream. So here's an example from the Philippines, right, of what data could be available to you and how you need to slice or dice it. The Philippines Department of Health has daily data drops and public dashboards so that organizations can access their data pretty granularly on a daily basis. My team built a huge chunk of this for the Department of Health, and the key elements for decision making around this are you want to get this health data. Ideally, you're in a country with open data standards around public health. You do need testing data, do need positivity rate data, and you do need pretty granular locations for where the cases are and where the clusters are. Once you have that, you can then map those locations and you can map your government's facilities, available capacity for dealing with COVID outbreaks to your locations. And so the spatial component of this is actually like very, very key. So the second data stream that you need is consumer behavior data sets. And why do you need this pretty rapidly? You need this because COVID represents probably the biggest shift in consumer behavior that we've seen in the last 20 years. This is a chart from a McKinsey report, a study that they ran in June. And it says that 75% of consumers have tried a new shopping behavior, and most of them intend to continue these behaviors post-COVID. So the way to read this is 40% of the people McKinsey interviewed have tried a new shopping method in the last 3 months. And of those people, 73% intend to continue with the new methods they've found. So think about your customers, right? 33% of your customers, if you're a retailer or a store, have tried a different retailer, a different store, a different website. And of those people, 79% intend to continue. So this represents a dramatic switching behavior for your customers. One that you could take advantage of, or you could lose because of this. So one way of thinking about this is that it is an opportunity to snipe market share from your competitors. 33% of their audiences and customers are now looking around all of a sudden. And it's also a bit of a threat to you. A third of your customers are looking elsewhere. So you need to be able to respond really, really quickly to them. I strongly suggest here what I've seen that works pretty well is running surveys through digital means, so texting, email, WhatsApp, Facebook, with focus groups of your consumers, or just a random sampling of your existing customers, and doing it on a repeating basis that you might not be used to. So instead of doing it every 3 months, really think about doing it every week until things settle down. The third data stream that is super useful for tactical planning is mobility data. So here's an example of how mobility has really been shifting in the city that I live in. So in Manila, this is data from Waze's Connected Citizens program. We can see that mobility really shifts when it really shifts in reaction to different levels of lockdown and restrictions. So you can see between February and June, we went from we had a very hard enhanced community quarantine. Nobody could go anywhere for any reason for 2 months. And then we had modified enhanced community quarantine, which released some of those restrictions. And then after a few more weeks, we switched to a level of quarantine that was like even lighter. And you can see on this visual here, where instantly on ECQ, the number of jams, the amount of traffic on the road just slams shut, and recovers pretty well for ECQ and GCQ. When you view this sort of data on a spatial basis, you can see which districts are recovering, and which mobility is a bit of a leading indicator. That's one thing I quite like about it. By the time you see store sales, and by the time you see store sales, it's actually a bit of a lag already. Mobility patterns can tell you a few days in advance whether people are moving out of the areas that you serve, whether businesses are coming back where you are, and so on. So let's take a look at this next slide, right, which shows a different flatter view of this. My main takeaway from studying mobility data for the last 6 months, at least for Metro Manila and the Philippines in general, is that policy strongly determines mobility, not COVID cases, not more than people's fears. It's actually government policy that more strongly determines the level of vehicle mobility. Of course, mobility isn't just limited to cars. Mobility is at its heart people, and how people move through the places we live and work in. When you get mobility data, you have to be pretty careful not just to capture what's obviously available in front of you, but to capture data sets that can span car data, public transit data, human mobility in terms of pedestrian movement, if available. Really, how are people's origins and destinations changing as our reactions to COVID change? Just to show you illustratively why this is important. In Southeast Asia, drivers are back on the road. If you look at Jakarta, Kuala Lumpur, Hanoi, Bangkok, in all these cities, driving activity has returned to, and in some cases exceeded, its pre-COVID baseline. But public transit ridership in the same cities remains 10 to 70% below the baseline. In the short term, this mobility data tells you a lot about the effectiveness of government interventions. In the Philippines, just by looking at Waze data across the country, we can tell when the local government units are imposing stricter curfews or changing their rules around who's allowed to go where. In the short term, you can also infer a bit about economic health from mobility data sets, because really to move is to live, economically speaking. And in the long term, places orient themselves around mobility patterns. A car-first city looks and feels very different from a train-first city, which looks very different from a pedestrian-first city. And cities will be responding differently over a longer time scale, depending on how their response to COVID, how effective or not it is. So let's switch focus from short-term to long-term, yeah? So in terms of the long-term pain and long-term planning, well, we're in for a lot of long-term pain. The World Bank forecast a global GDP contraction of 5.2%, the deepest recession in over 80 years. And all signs are pointing to this continuing to worsen. If we're lucky, it'll be like COVID, where Hong Kong, Singapore, and Taiwan all recovered to their pre-SARS levels in about a year. But SARS was dealt with much more quickly and hit far fewer geographies than COVID. So we really should expect to be modifying the way we think strategically. We need to think about our observe, orient, decide, act cycles and make sure that all of our organizations can go through these cycles relatively quickly. Because there is so much uncertainty, you need to be a lot more observant, and you need to orient. You need to take a lot more time to orient yourself properly, and that means getting new data sets, leveraging new data sets for economic indicators. There are so many ways we could potentially be recovering. It could be a V-shaped recovery, a U-shaped recovery, L-shaped, K-shaped. Really, does anybody truly know? So under these conditions, my team has developed a framework for capturing spatial analytics data streams in a way that supports organizations in that kind of strategic planning. The way we have thought about this is we start by collecting data that is in machine readable format, then detecting data, spatial data, observable from space, from satellite imagery and point of interest data sets. Then you infer data that you cannot directly observe using spatial analytics, using machine learning, and that gives organizations what they need to be able to analyze and go through that OODA loop very quickly. So let's talk about this piece by piece, right? This most straightforward piece is collect. All spatial data sets should be linked by location. In some cases, it's more challenging than it seems to link data by location. Where you have public data sets coming from government, where you have theoretically public data that's locked into scanned PDFs, where you have data set accessed by API, get it all, collect it all. That's your first step, no-brainer. Then once you have that, you can use AI on satellite imagery to extract geospatial features. So the detect piece, that's where it comes in. Here are a few examples of models for detection. You can use AI to identify building footprints, to just detect where buildings are and to be able to classify them as commercial, residential, warehousing. You can use machine learning models for building height estimation, being able to figure out the level of density in different spaces. You can use ML models for land use classification, and so many more options. So the detection step comes next. After detect, you then infer. So things that are not immediately observable, you could infer using spatial analytics and machine learning. So here's an example of how that might work out, right? You start with your existing data sets, the machine readable data sets you've collected, the features that you've extracted from satellite imagery. You then have this all in a big geospatial feature store. So you have things like how many swimming pools are there, where are all the swimming pools, where are all the golf courses, the tennis courts, the cars, residential area, forested area, population. Those are all in your geospatial feature store. And from there, you can infer things like how many people are more than 10 kilometers away from the nearest health facility. So we've been working with the Department of Health in the Philippines on a variety of health access and COVID data analytics. And so we put an example of how you can load up big data on a visual layer to very quickly identify where the people are who might need further assistance, who might need, in this case, better access to health facilities, and should be the first people to be targeted by digital health campaigns. Here's the next example of how of inference, right? So for a telco in the Philippines, we worked with them to help them take effectively like a 1 year process and turn it into a 2-week process. So for identifying households and inferring the wealth of each household in order to determine where they should roll out additional telecommunications facilities. This is something that you can use, you really use machine learning to do very productively these days. So once you have all of this, right, you then have a very rich set of data streams to build back into your analytics practice. You can then ask questions like, where do I put up new branches? Where do I permanently close existing branches? Where should I go to reach my customers? Where are my potential new customers moving to? All of this with a spatial layer, and all of this happening in very fast iterations. And with that, I have one last thing to say. It's been an extraordinary experience building data systems in the last 7 months. The tools, techniques, the data sets that this community has developed have all been extremely useful in our work and helping our enterprise clients really redefine the way they do business. Thank you for being part of the spatial data science community. Thanks for listening to me talk, and please feel free to reach out. Super excited for the rest of this conference and hope to catch some of you later. Hello, everybody. I changed. Thank you for watching my talk. Really appreciate your time and attention all around the world. So I have a few questions to tackle here. First is, where could we download the presentation paper, the methodology? Thank you for being interested in the methodology. If you go to our blog, or our GitHub repo, those are probably the two best places to go. We go pretty in depth. So as a company, we're interested in open source poverty and wealth modeling because of our developing nation setting. If you go to stories.thinking machines and just kind of scroll through it, it's also interesting to go through time and see the iterations of what we've done, like the version 1 of replicating Stanford Sustainability AI Labs paper that was mostly focused on nightlights, and then an updated version that included more geospatial features coming from OpenStreetMaps. And now we're looking at using data sets that are coming from digital marketing companies and telecommunications, open data sets to help us understand better, to help us see, for example, there's this one really cool pattern we see in the Philippines at least, where 4G access is a strong indicator of improving socioeconomic outcomes. Now, whether that's just causal or correlative, we still don't know, but it's an interesting indicator. So please do check it out. I hope if you continue to write papers or use our code, please build on that. I think it's a very powerful new set of methods we all have access to now, especially with cheap satellite imagery. The second question I'm seeing is about the 3 useful spatial data streams. Where do I recommend we look for such open source data sets, or how easy is it? So just to quickly recap for everybody, the 3 most useful spatial data streams I've found as we build these tactical data sets is first public health. So that one, it has to come from the government. The good news is it's always going to be free. It is a public health data set. But what I've noticed is on a country-by-country basis, countries are very varying in their ability and willingness and granularity of what they're going to share. So in the Philippines, my team built the public-facing dashboards and handled the open source data or open data drop for the Philippine government, and that was hugely challenging project, which I might be able to talk about 2 years from now. But ideally, if you are operating in a country where your government is providing data sets, it doesn't matter if they're not daily, but what you want to look for is more granularity in terms of location of where cases are occurring and where case spread is occurring. But if you're not in one of those countries, then I really would look to proxy indicators, which your best proxy indicator is probably the government's degree of lockdown and response per municipal unit. That's the next best proxy data set. So the second data set is a consumer behavior data sets. This one, I would not count on getting this open source. If you are a company, the cheapest, fastest, most effective way of doing this is just reaching out to your old customers. If you have a loyalty card system, or if you have, I'm sure you have some sort of customer touch points, and setting up focus groups. And I really would emphasize the need for a pretty frequent cadence, because buying patterns, consumer patterns, where people are even moving to, in terms of their living situation, in terms of COVID, change pretty rapidly. So these weekly focus group check-ins that you run yourself where you connect to your own customers through email, through Facebook, SMS. That is what I would strongly recommend. That's way more effective than and way faster than paying for a marketing research firm to do it for you. Third, when it comes to the mobility data set, so if you look at the Thinking Machines blog, we are research partners with Waze, and we've found Waze to be a very, very powerful data set for telling us where vehicles are going. If you are in a city which uses Waze, you can request access to the Waze Connected Cities program, where they do have, they will share data under like a research agreement. If you are not, what I would suggest is getting open source mobility data sets from the from your local municipalities. That one is a little bit tricky. I'd actually like to mention a fourth data set, which just came out 2 days ago, which I find to be a super interesting, purely open source data set. So that would be the Ookla speed test data sets. So that data set gets very, very granular in terms of geospatial and tells you the speed tests, the internet upload download speeds of various places in a very granular way. So that is a strong proxy indicator for where people are who can access your website, your products. I think that's pretty rich. Yeah, and that's. I see 2 more questions, and I think I'm going a little bit over time, but since Flo isn't here to stop me, I'll answer these 2 and then end us here. So question about the Singapore COVID response. We did not. The Singapore team, the data set is called the Ookla data set. I'm just gonna type it in here, Ookla. Actually, I could probably get us a link right now, Ookla open source data set. So that's pretty powerful. Yes, that's it. We did not work with the Singapore COVID response. The Singapore technology teams working for the government are excellent. They're some of the best tech public servants I've ever met. So they run their own response. But my team works for private sector clients in Singapore. So if you are in Singapore and you want to talk, you have my email. And yes, thank you for noticing the public versus private transportation recovery piece. I really did want to emphasize it in this presentation because when we talk about new mobility, it's easiest to measure cars, right? But true mobility is multimodal, is people-centric. So just because it's like as data people, I do think we have a responsibility to not just analyze the data sets that are most obviously available to us, but try to seek to expand our ability to measure, analyze, and make recommendations about the world around us. So yeah, thank you, everybody. Thank you so much for giving me your time today, and I hope to be talking to some of you over digital.